Well, welcome back to the farm, friends. So today, we're not just feeding sheep, watering crops, or learning a new thing about history. Today, we're feeding our brains. Math is one of the most powerful tools on the farm, and today we're going to learn a rule that keeps everything running smoothly. It's called the order of operations. So for those of you who don't know me, I'm Miss Bree, educator, farmer, illustrator, singer, and proud grammar nerd. And welcome to the farm school. So first of all, everybody say hello to Tilly. Tilly is a Teeswater sheep, a rare and critically endangered breed, known for her long and shiny wool. Just like Tilly is special, math rules are special too. They protect our answers and keep them accurate or correct, especially when big decisions depend on them. So, what is the order of operations? Well, imagine if three farmers solved the same math problem, but each one did it in a different order. They could get three completely different answers. The order of operations is like a universal rule book. It tells everyone exactly what to solve first, second, third, and fourth, so that we all get the same correct answer. Why is it important? Well, on a farm, small mistakes can turn into big problems. If we mix up our math steps, we might buy too much fertilizer or not enough seed. So the order of operations prevents costly mistakes, creates a step-by-step system, ensures accurate or correct results, and is used in real careers, especially agriculture. So there's two popular mnemonics, and these are memory helpers. So the first one is PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. The second one is BODMAS, which means the exact same thing, but it's brackets, orders, division, multiplication, addition, and subtraction. Either one is fine, okay? They both mean the exact same thing. So let's break it down, okay? First, you do parentheses or brackets. Okay, that's the first thing you do. After those are done, then you move on to your exponents or orders. Okay, once the parentheses and exponents are done, then you move to multiplication and division. So multiplication and division are equals. So whichever one comes first in the equation, we're going left to right, that's the one you solve first. Okay. And then you go from there, once you're done with your multiplication and division, then you go into your addition and subtraction, and that's the same as multiplication and division. Addition and subtraction are also equals. Solve left to right, right? They're best friends. Multiplication and division and addition and subtraction, they're buddies. So, you know, you want to be fair, so you need to do whatever one comes first, not pick one. Okay? So, step one is parentheses. Parentheses are like fenced areas on a farm. You handle what's inside the fence first. So, for example, we have parentheses 6 plus 4 times 3. So, first we solve inside the parentheses, okay? And that's 6 plus 4. That equals 10. Then you finish the equation, right? You pull that 10 down and replace the 6 plus 4. So now your equation is 10 times 3. Then you multiply 10 times 3, and the answer is 30. And you always solve the fenced-in math first, right? And you always work from the innermost grouping outwards. Now that we've solved the parentheses, now we can move on to exponents or orders. Exponents are repeated multiplication. 5 squared, right? 5 to the second power, or 5 to the second order, 5 to the order of 2, however you want to word it, means 5 times 5. That equals 25. Exponents can make numbers grow quickly, just like crops in good soil. All right, so now that we've done that. Now we're going to move on to multiplication and division. These are teamwork operations. Remember, they're equals. So our first equation is 20 divided by 5 times 2. So remember, we're not going to multiply first just because it comes first in the PEMDAS mnemonic, right? We're just going to do whatever one comes first. So first, we're going to do 20 divided by 5, which equals 4. So then we're going to move the 4 down into our equation, and our new equation is 4 times 2. Then we're going to take 4 times 2, and that equals 8. That's right. So we don't skip around, we just move steadily across. And finally, we add and subtract, left to right, just like we did multiplication. So we're going to do 10 minus 3 plus 2 is our equation. So we're going to start with 10 minus 3 because that came first. 10 minus 3 equals 7. Now you're going to bring the 7 down, and your new equation is 7 plus 2. 7 plus 2 equals 9. That's your answer. So we always finish these 2 steps last. Okay, so let's do an example equation, okay? Now it's your turn to think like a farm mathematician. So, what comes first? Parentheses, then exponents, then multiply or divide, then add and subtract. Each problem is like planting seeds in the correct order. Skip a step and your answer won't grow properly. So let's help Tilly solve this equation. So our starting equation is parentheses 10 plus 4, end parentheses, times 3 to the 4th power, or to the order of 4, right, minus 4. What are we going to do first? Parentheses. Okay, so when we do parentheses first, we're going to take that 10 plus 4, and that equals 14. That's right. So now we're going to take that 14 and bring it down into our new equation, which is 14 times 3 to the 4th minus 4. Perfect. Now we do the exponent, right? So 3 to the 4th equals 3 times 3 times 3 times 3. That equals 81. So we're going to add that into our new equation. So now we have 14 times 81 minus 4. Next up, because multiplication comes first, instead of addition, there's only multiplication. So we're going to do that first. So we have 14 times 81 equals 1,134. Now bring that down into our new equation, and our new equation is 1,134 minus 4. And then finally, we finish with subtraction. So we have 1,134 minus 4 equals 1,130. So your final answer is 1,130. Great job, guys. Let's move on. So now let's solve another equation with Tilly. So this equation is parentheses 33 minus 16, end parentheses, plus 4 to the second divided by 4. So first, we're going to solve the parentheses. That's right. So we're going to say 33 minus 16 equals what? 17. That's right. 16 plus 17 equals 33. That's right. So 33 minus 16 equals 17. So we're going to bring 17 down into our new equation and say 17 plus 4 to the second divided by 12. So what do we do next? Our exponent. That's right. So 4 to the second equals 4 times 4. 4 times 4 equals 16. So then we bring 16 down into our new equation. So now we have 17, because we solved that first, plus 16, which is what we just solved, divided by 4. Third, we have division, because remember, division always comes before addition or subtraction. So now we have to divide. 16 divided by 4 equals 4. That's right. So now we're going to bring that down into our new equation. So now instead of 17 plus 16 divided by 4, we just solved that. Now we have 17 plus 4. That's right. So now we add. That's right. So we're going to do 17 plus 4 equals 21. That's right. So your final answer is 21. Great job, guys. Rory, go lay down. All right. Sorry, guys. Rory, my doggy here, is trying to help with the math. All right. So let's finish this equation now. Let's help Tilly with this equation. So our equation is parentheses 32 minus 4 in parentheses to the second power plus 12 times 3. I know I threw in another little additional complication there, but the same rules apply. So first we're going to add or subtract, right, the parentheses. So 32 minus 4. 32 minus 4 is 28. So we're going to move 28 down into our new equation. Our new equation is 28 to the second plus 12 times 3. Very good. Now 28 to the second equals 28 times 28. Perfect. That equals 784. So now we move that down into our new equation. And our updated new equation is 784 plus 12 times 3. Now what do we do? That's right, multiplication. So now we're going to take 12 times 3 equals 36. That's right. So now we're going to move that into our new equation. So now our final new equation is 784 plus 36. So now we're going to do our final round, and that's addition. So addition means we're going to take 784 plus 36 equals 820. So our final answer is 820. Great job, guys. So why does this matter? Why is this such a big deal for farming? Well, farmers like me depend on precise math to calculate crop yields. Okay, make sure we're going to get the right amount of tomatoes from our field. We need to measure fertilizer, plan irrigation, or budget for supplies. A small math mistake can cost us thousands of dollars. For example, with fertilizer, if a farmer applies too much fertilizer, your money is wasted, number one, and two, your crops can actually burn from too much fertilizer. And of course, if you have too little, your crops won't grow properly. They don't get enough food. So correct math equals healthy plants. So let's do a real world scenario, okay? So for this one, a farmer needs to fertilize 12 acres, right? Each acre needs 50 pounds of nitrogen per acre. The fertilizer blend is 25% nitrogen. So how much total fertilizer is needed? So step one, we're going to multiply 12 acres times 50 pounds of nitrogen per acre. That equals 600 pounds of nitrogen because multiplication comes first. So we know that he needs 600 pounds of nitrogen in total. But wait, the fertilizer is only 25% nitrogen. So what do we do now? Well, next we need to divide that 600 by 0.25 because it's 25% of 1. So 600 divided by 25% or 0.25 equals 2,400. That's right. So because one bag is only 25% nitrogen, we need to quadruple the amount of fertilizer that we need to achieve that correct 50 pounds of nitrogen per acre. So 600 divided by 25% equals 2,400 pounds of fertilizer that is needed. So you see how order matters? All right. So now let's bump it up a little bit. So here's our new problem. So a farmer, maybe next door to the other one, fertilizes 10 acres. the recommendation is 40 pounds per acre. However, the soil already contains 5 pounds per acre. So the soil only needs 20% nitrogen now, right? The fertilizer is only 20%. So if the soil already contains nutrients, we're going to subtract first inside parentheses and then multiply and divide, right? So our first equation is 10 times parentheses 40 minus 5 end parentheses divided by 0.2 because it's 20%, right? 20% is 0.2. So, of course, we're going to do parentheses first, right? So even though it's subtraction, but it's in the parentheses, so we're going to do it first. So 40 minus 5 equals 35. So our new updated equation is 10 times 35 divided by 0.2 or 20%. So our next thing we're going to do, which comes first in the list, right, which comes first in the lineup, is multiplication. That's right. So 10 times 35 equals 350. So what's our new equation? 350 divided by 0.2 or 20%. So our last step is to divide 350 divided by 0.2 or 20%. This equals 1,750. So the farmer needs 1,750 pounds of fertilizer. So you see how it makes a difference what the fertilizer contains, right? Our first farmer had fertilizer that contained 25% nitrogen. This farmer has fertilizer that only contains 20% nitrogen. So it makes a little bit of a difference how much you actually need to use. But you did a good job, guys. All right, let's keep going. So let's talk about how we would use this for like irrigation, right? How do we water our crops? Well, same thing. We still have to use the order of operations, right? If we use too much water, we drown our crops and we waste resources. If we don't water them enough, that causes drought stress and they could die. So math helps protect the harvest and the food you eat. So, for example, let's talk about this farmer who needs to irrigate or water 15 acres of crops. Okay? Each acre requires 0.75 inches of water. Okay, 3/4 of an inch of water. Also, each irrigation system delivers 0.25 inches of water per hour, or 1/4 of an inch of water per hour. So your goal is to find out how many total hours should the system run, right? So number 1, we're going to write our equation. So to find the total irrigation time is required water per acre divided by system delivery rate. So the required water per acre is 0.75, right? 75% divided by 0.25, 25%. Okay, so notice we divide because we're figuring out how long it takes to reach the required amount. Step 2, division, right? So we're going to take 0.75 divided by 0.25. That equals 3 because 0.25 goes into 0.75 3 times. So the irrigation system has to run 3 hours. You'll notice that we didn't mention the acreage here. That's because we didn't need to multiply by acres, because the inches of water applies uniformly across the field. So that means that, he's watering those 15 acres of crops all at once, right? So it doesn't matter how many acres it is. We still know that we only need to run the irrigation system for 3 hours to achieve that 0.75 inches of water. Great job, guys. So when we use the correct order, we save time, we reduce mistakes, we simplify complex problems, and we build confidence. This is critical for high-stakes farming decisions. So imagine this formula, right? Seed plus parentheses, fertilizer plus acres, end parentheses, plus labor. Okay, if we multiply before adding, we get the right total cost. If we add first, our budget is wrong and we won't make any money. And we might not be able to pay anybody on our farm. Farm businesses depend on this accuracy. Now, a universal math standard means that farmers, agronomists, farm managers, and community teams all reach the exact same answer, and that consistency builds trust and better teamwork. So, the big takeaway here, the order of operations creates accuracy, prevents mistakes, supports smart decisions, and builds strong math thinking. So, math truly matters in farming. So, let's do a recap one more time. We have PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction. We also have BODMAS, which is brackets, orders, division, multiplication, addition, subtraction. Good job. So you can pick whichever one of those work best for you and take it with you, okay? And I'm really glad you guys came today. So thank you for visiting Farm Math. So remember, every strong farm runs on smart decisions, and every smart decision starts with clear thinking and correct math steps. All right? So keep practicing and keep growing. I'll see you in the next video.